nuclear propulsion would open up space exploration, but there are some serious challenges that we would have to overcome first. The nuclear engines would need to be safe and lightweight, and that isn't easy to achieve since they'd be operating at a temperature of 2,430 degrees. And this wouldn't be the first time we would try using nuclear power in space. In 1958, Project Orion was a rocket design that tested a nuclear propulsion system. And let me tell you, it was bizarre. Instead of using anything that resembles our current rocket engine, Project Orion used blast waves to propel the spaceship forward. Yeah, you heard me. Blast waves. Orion would eject small nuclear bombs behind it, one at a time. A few seconds later, boom! The coffee can-sized bomb detonated. Plasma from the explosion would catch up with Orion's back, then hit a thick, shock-absorbing plate. This would protect the ship from the radiation and move it forward. Every time a bomb detonated, the space vessel would gain speed. The idea was that by using this technology, you could increase velocity so much that you could reach any point in the solar system in 1 year. But the idea of casually detonating nuclear bombs in space didn't sit well with a public that already feared nuclear power. So Project Orion was terminated. Fast forward to today, and we have a new opportunity to use nuclear power in space. But not by using bombs. Instead of using bombs to get to Mars, we'd use a nuclear thermal propulsion system with a reactor core. This reactor core would be 8 times hotter than nuclear power plant cores. It would heat fuel, in this case liquid hydrogen, to 2,430 degrees, turning it into a gas and creating thrust. Right now, the nuclear thermal propulsion system would use fission to heat the reactor core. Fission splits a larger atom, usually uranium, into at least 2 smaller atoms. But in the future, when we've got the right technology, we could use fusion instead. Fusion is the opposite of fission. It would join at least 2 smaller atoms into a bigger one, releasing up to 4 times more energy than fission. That would be one energetic rocket.
Wow, that's very impressive.
And a quicker space trip wouldn't just be convenient, it would also be safer for the crew. Astronauts are exposed to cosmic radiation when they're in space, which can cause serious long-term health issues. Radiation shielding could help, but it's extremely heavy. And the longer the mission, the more shielding you'd need, so by reducing your time spent in space, you'd limit the crew's health risks, and the mission would cost less. And we'd use these rockets for more than transportation. Once a rocket has reached its destination, the nuclear reactor could switch from a propulsion system to a power source. So, what are the drawbacks to nuclear thermal propulsion? Well, you could only use this system when the vessel is in space. It would still need chemical thrusters to leave Earth. There could be a lot of radiation effects, so the farther away from Earth's atmosphere it is before the NTP systems switch on, the better. And the word nuclear sets off a lot of alarm bells. We'd be dealing with explosive radioactive material after all. But the nuclear propulsion system would be designed so that even if there were a launch failure, only a minimum amount of uranium would disperse, reducing any radioactive spills. Scientists have studied this type of engine since the late 1950s, but it hasn't flown in space yet. Regulations and lack of funding have slowed its development. But in 2019, NASA received $100 million to develop nuclear thermal propulsion, making their 2035 plan of sending humans to Mars much more achievable. Nuclear energy could be the future of space exploration.